Welcome back. And so in this video we're going to create our physics body, okay? And it's the physics body that's going to allow us to apply a force to the ball node, okay? And so to create a physics body we first have to create a physics shape, okay? So underneath the ball node position we're going to write this. We're going to write let physics shape, okay, equals SCN physics shape, okay? And so physics shape, or SCN physics shape, is a function which takes in two arguments. Now the first argument is the node, okay, and then the second argument is options, okay? Now for the node we're just going to pass it ball node, okay? So ball node, okay, and then for options we're just going to pass it nil. Okay, so now that we have created the physics shape, let's create the physics body. Okay, so to create a physics body, we're going to write let physics body, okay, equals SCN physics body. Okay, I'll just change the C to a B. Okay, so yes, SCN physics body. Okay, now SCN physics body is a function which takes in two arguments. Now the first argument is the type of the physics body, so type, okay, and then the second argument is the shape of the physics body, okay. And so for type we're just going to write dot and then dynamic, okay. Now because the type of our physics body is dynamic, we're going to be able to apply forces to the physics body, okay. So if the physics body is hit, it will move, okay. And then for the shape we're going to pass it the shape, so physics shape, okay. So we're going to write physics shape, okay. And so now that we have created the physics body, let's apply the physics body onto the ball node, okay. And so to do this we're going to write ball node dot physics body, okay, equals physics body, okay. And so because the ball node now has a physics body, we're now able to apply a force to the body, okay. And so what we're going to write to apply the force is this. We're going to write ball node dot physics body dot apply force, okay. And apply force is a function which takes in two arguments. Now the first argument is the direction and the second argument is as impulse, okay. And for direction we're just going to pass it an SCN vector free, so SCN vector free, okay. And recall what we've said that the SCN vector free takes in three arguments, so we have the x, y and z axes, okay. And for the x-axis we're just going to give it the value camera position dot x, okay. So camera position dot x, okay. And then for the y-axis we're going to give it camera position dot y, okay. And then for the z position we're going to write camera position dot z, okay. And as impulse is going to be set to true. And so now that we've applied the force to the ball, let's run it, okay. Let's run it and let's see what we've done. Okay, so what should happen now is this. When the game is run, when we tap on the screen, a force should be applied to the ball. So let's just tap on the screen. Okay, so when we tap on the screen, the ball just falls to the ground. That is just okay, but it could be much better. So what we need to do is, in passing the direction, we also need to pass in a force, okay. And so to do this we're going to write this. We're going to write let force vector, okay, be of type float, okay, and force vector is going to have the value of 6, okay. And what we're going to do, for every axis we're going to times it by 6, okay. So we're going to write camera position dot x multiplied by force vector. Okay, and we're going to do the same for the y-axis. So again, multiplied by force vector. Okay, and again we're going to do the same for the z-axis. So multiplied by force vector. Okay, and so now let's run the game again. And what should happen now is that the ball should actually start to move. Okay, or move forward at least. Okay, so we have the basketball net or the basketball hoop. So let's tap on the screen. Yes, and it works. And what we can see now is that the basketball is being launched forward. This is good. But you know what's currently happening is that the basketball is just going straight through the backboard. And this is because we haven't yet added a physics body to the backboard. Okay, and so this is what we're going to do now. So let's pause the game or stop the game, and then in the add backboard function we're going to add the physics body. Okay, and so to add the physics body we're going to write this. We're going to write let physics shape, okay, equals scn physics shape. Okay, and for what we've said that scn physics shape is a function which takes in two arguments. And so the first argument is the node, okay, and then the second argument is options, so OPTIONS, okay, and then for the node we're just going to pass it the backboard node. So let's write backboard node, okay, and then for options we're just going to pass it nil, okay, and we will change this in a moment, but we have an example to show. Okay, so now that we have the physics shape, let's create the physics body. So to do this we're going to write let physics body, okay, equals scn physics body. Okay, and recall what we've said that scn physics body is a function which takes in two arguments. Now the two arguments, or the first argument, is the type of the physics body, and then the second argument is the shape. Okay, and so for type we're going to write dot static. Okay, and this is because when the backboard is hit we don't want the backboard to move. Okay, we want a static body, so an unmovable body. Okay, and then for shape we're just going to pass in the value physics shape. So let's write physics shape. Okay, so now that we have created the physics body, let's add the physics body to the backboard node. Okay, and so to do this we're just going to write backboard node dot physics body equals physics body. Okay, and so now that we've done this, let's run the game. And what will happen now is this: when we shoot the basketball at the backboard will bounce off the backboard. Okay, so let's shoot. There we go. There we go. It's much better, right? It is much better. You know, now let's try to score, or let's try to get the ball into the hoop or through the hoop. Okay, so what we can see now is this: the ball literally just rolls over the hoop. Even though it should fall, it just rolls over the hoop. Okay, now what we're going to do to solve this is this: we're first going to pause the game, okay, and we're going to change options, okay, from a nil, okay, and we're going to add a square bracket for an array, and then we're going to write this: scn physics shape, okay, dot options, or dot option dot type, then a colon, okay, then scn physics shape, okay, dot shape type, okay, so dot concave polyhedron. Okay, so what was happening was that when we shot the ball just rolled over the hoop. Okay, and this is because Xcode was interpreting the hoop and the backboard as one object. Okay, and because of this it didn't take into consideration the circle or the sphere. Okay, and so now that we have written scn physics shape, ball.shapetype.concave polyhedron, SceneKit will now detect all the details of the models, okay? So it will closely align the model, okay? And so because of this, SceneKit will now know that this hoop, okay, is a torus, or this hoop is a ring, okay? And that there's a hole in the ring, okay? And so if we run the game now, what's going to happen is that the ball is now going to fall through the hole. So again, let's shoot. And we got it in. And we got it in first try. That's good. Can we do it again? Great. This is great. Okay. This is really good. How many can we get in a row? Not a lot. Okay. And so this is it for this video. And what we've done is to add physics bodies to the ball and the backboard, okay? And so in the next video, we're going to create our first action, okay? And so I'll see you all in the next video. Thank you.